Hi everybody. I think this rainy weather in Amsterdam does make you sad. Last time I was in Amsterdam it was sunny. So I will talk about the authorization protocol, or to be more correct, about the Facebook's implementation of this authorization protocol. So the topic becomes hot. You even saw another talk on the Prelude track yesterday about the abusing Twitter's API and OAuth. So indeed, we haven't had such problems we have now with the web. We've got millions of users on Facebook which share their data. We've got millions of app developers which need their data for different purposes like advertisement, entertainment, or personalization, or anything else. And the authorization protocol is something which gives both sides, the users and the developers, a way to retrieve their data and to use this data and to give some kind of control about this process. So I will explain that there is still much of stuff we should understand to build secure OAuth implementation. So first, about myself. My experience in OAuth was mostly restricted by and also driven by the Facebook bug bounty program. So everything which could be solved would be a major issue. If it's an abstract weakness, or it's bug not in Facebook but in some third-party application, if it can be exploited directly for executing code or for stealing some private data, it's not a major issue. So, but I also from academia, so I study in Human State University. I tried to fit everything about the OAuth background into one slide. Anyway, you had another talk about the OAuth, so you should have at least some background into how this protocol works. But anyway, first, there are 4 actors in this protocol. Resource owner authorizes client, which is the third-party application, to access his data and to resource owner. There is also the authorization endpoint. In the case of Facebook, authorization endpoint and the resource owner, resource server are the same. So the simple idea is that the password is never given to the third-party application, only access token. There were many attacks onto the OAuth implementation. I've just pulled a couple of things. Also, it's a pity that my coworker, Egor Homakov, is not here, so I'm missing lots of cool bugs by him. But anyway, there are also fundamental problems about the OAuth. I think the most notable is the session fixation, which was found in the Oaus 2.0, because there was an interference between the bug in the standard and the actual business impact. I think it was Google, if I'm right. So, another simple idea which lies behind the authorization protocol OAuth 2.0 is that the data, the kind of credentials, access tokens, or codes are transmitted cross-domainly via the redirects. So I've put just 2 pictures of 2 flows. There exist 2 flows in the OAuth 2.0. The first is implicit grant flow, another is authorization code grant flow. So the first one is considered at some point less secure because it gives directly the access token to third-party application. Look at the point C. The second flow could be used, if correctly implemented, for the authorization purposes, because the client has to exchange the code. Look at the point C. It's code, it's not a token. It should exchange it for token using the secret key. And this backend flow, D and E, is never seen to user. It happens all in backend. So what makes it interesting to explore the OAuth 2.0 and its implementation on Facebook? Well, first, because OAuth 2.0 is a proposed RFC standard. I think it's placed at the as some kind of replacement for OAuth 2.1. But anyway, OAuth 2.1.0. But anyway, the first version of OAuth is still alive. Well, another reason is that Facebook is the largest platform for developers. They've got millions of users, 1 billion, I think, and 10 million applications. So you would never think, you would never see the same problems the Facebook has, I mean, at that scale, at the scale of Facebook. And it also turned out to be that there's large attack surface, which is poorly explored. There is also a fourth reason. I tried to fit it inside the picture. So I would define a threat model in a pretty standard way for all the researchers who research the authorization protocol. It simply answers one question: what harmful can happen if I click the malicious link? So exposing private data or invoking some unwanted actions could be performed if you have an access token. So leaking access tokens would be interesting to me. Also, signing into third-party account with the Facebook authentication will be also interesting for me. It's authentication bypass. And the executing code, I mean the cross-site scripting, would be the perfect goal of breaking this protocol because it would allow everything. So I will start with a very, very easy bug, but very simple yet very hard to patch. So this script, external login status, PHP, exposed token in a query string instead of hash. So this is a direct violation of the standard, and it could be easily exploited to leak the access token. Just insert a picture into the somewhere inside the client side, then the temporary redirect to your right to point this page, and then let the user click the link. When the flow goes to the page where the redirect to your right points, your picture is being loaded from your server and you just pick up the referer. Well, it's very simple. I've just put a picture inside the Bing. So I used the Bing application as an example and leaked the access tokens. So very easy to understand, very easy to spot. Why would this worth talking about it at all? Well, how would you patch it? I reported this bug maybe one year ago, and it's still not patched completely. Because if you've got external developers which stack up to your protocol, you can't change everything without breaking something. So it will remind us that the design bugs are the most expensive. So, but not only design bugs are a headache. In the next paragraph, I will talk about the piece of code written by Facebook in order to simplify the developer's task. Well, what the JavaScript SDK does is actually can be defined as follows. Given the string with the URL fragment, how to safely parse this and how to safely transmit this data into third-party application. So the JavaScript SDK does lots of stuff, but the main thing is just transmission of tokens from a URL fragment into the application's domain. So the flow works like this way. So everything spins around the Facebook proxy iframe. For various reasons, because of different browser behavior, it consists of two iframes, or window and iframe. The top iframe is the actual proxy iframe, and the bottom is the window. And the bottom iframe calls the proxy message function, while the proxy iframe with that function implementation calls the post message and transmit the actual access token to the application's domain. Well, the bug was that there was no origin checks. So I was simply loading and setting up the Facebook proxy iframe, prepared for some trusted application, and injected it into my own domain. So that way, I got the tokens which were supposed to belong to some trusted application, not to me. So I think lots of bugs were submitted to Facebook regarding to this issue. Because they patched this, they added origin checks, but they added this incorrectly. Then they patched it again. I think my bug was just one of those bugs where I tempered the redirect URI to point to the old version of XD proxy, where there were no those origin checks. So I bet this small JS SDK script has the biggest density of bugs in case of Facebook. And also this is exactly the case when there's something completely beyond the standard. So the OAuth standard does not define how the tokens should be transmitted. And the Facebook implemented something out of standard and got lots of bugs. So the next paragraph will be about, I would call this attacking the core OAuth defense mechanism for XSS tokens, its URL fragment. So the whole task for this chapter would be how to extract, how to leak XSS tokens with the tricks with URL. So first, I think everybody has seen the so-called hash bank navigation into Facebook. So it can be abused to pull the data from the safe place, safe for XSS tokens, it's called fragment, into the URL string, into the URL parameters, where this sensitive data is vulnerable to leaking via the referrer field. So I've submitted maybe 4 or 5 bugs, I don't remember, and they all worked in the pretty same way. First, redirect to some permitted Facebook page, then to pull the XSS tokens from the URL fragment, then to redirect to your own domain, and then to pick the referrer field. I will not give all those bugs description because, well, the exploitation method is more interesting than those bugs because they were pretty much simple. Another URL hash trick was related to the application Rpc, how it worked. I will give more details how Rpc works on Facebook. So basically there is an application, there is a Facebook app controller. They are in different iframes and they talk to each other with some messages. And the application can invoke some calls, so ask Facebook to do something. And there was a special method called getHash. It was used obviously to get the full hash contents. And if you remember, the XSS token sit inside this hash. So I built an application which just invoked this call, get the full hash contents. And I also relied on the hash bank navigation to bypass filters on the direct URI. So I think this method, I mean, the getHash method was used for parameters passing to the application or for navigation purposes inside the application. I don't know. I think it was a legacy method. It was removed just right after I reported this bug, so nobody used it. So I'll give a few seconds to understand how this flow worked. So first, sending the message to the proxy iframe, the Rpc message, then posting this message, then handling this message by the Facebook app controller, then the Facebook exposed the full hash content to the application.com domain. So what's interesting here is that if you've got fragment-based navigation into your authorization endpoint domain, think twice how it coexists with your OAuth implementation. Facebook also shipped out the so-called PHP Sdk, and in this paragraph I will talk about more interesting issues, such as bypassing the authentication and the fixating session. So it will be abusing the client, not the Facebook itself. And what's interesting here is that I'm going to abuse the, at some point, bulletproof authorization code grant flow, not the implicit grant flow. So looking into the PHP Sdk code, what we can see that the code is issued with an empty redirect URI. So standard, the Oaus 2.0 said that stealing code via redirect URI tampering gives nothing. Because if you just tamper the redirect URI and submit the code to the third-party application, it will not accept your code, because at the backend flow, he will ask the Facebook, like, give me the access token, and the redirect URI was like this redirect URI. And the Facebook says, no, it was issued for another redirect URI. So you will not be able to bypass the Facebook authentication. But using the Facebook PHP Sdk, it is possible. So whenever you steal the code with tampering of redirect URI, when the redirect URI points to facebook.com, you can just submit this code and you will be authenticated. So look at these two pieces of code. First gives you the downgradation attack. So there is another thing in Facebook called signed request. It's actually the JSON object with access token or with code and signed. I think it's part of OAuth 1.0 standard. And the thing is that according to PHP Sdk logic, this kind of authentication has more priority over the code-based authentication. And also look at the bottom piece of code. The signed request is parsed from the actual URL parameters. And there are no CSRF checks. So the session fixation is possible. Which sites use the PHP Sdk? It's out of scope. I've checked everything with one site, I think it was freelancer.com. So everything I talk right now worked on that site. So I could bypass the authentication, I could fixate the session, and who knows, well, I think many clients use PHP Sdk, and many of them, of course, do not patch it and do not look inside the code. So don't trust the external SDK. And I think PHP Sdk is not for safe authentication. If you would like to implement the client for Facebook, you should write your own implementation from scratch. I mean, the server-side authorization grant flow implementation. And also, bugs are not patched yet, so you can see the source code into the GitHub. Some time ago, Facebook changed the ideology of building applications. So first, it was just a page, the HTML page with some markup language. I think it was called XFBML. Now, the Facebook application is actually the iframe, which is loaded inside the Facebook window, and the way the application works with the application controller, the way it interacts with Facebook is kind of sandbox mode, because it cannot retrieve the data about user directly. It can only invoke the RPC calls to the app controller, and the app controller gives the data back to the application. So I found one magic RPC call. It was called show dialog. In order to render this dialog, just Facebook made a request to special endpoint and retrieved the JSON. The JSON contained the data, and the Facebook showed this dialog to the user. Where's the OAuth here? Well, the thing is that the same endpoint used for dialog rendering was used for OAuth, because the authorization dialog sit also at the same endpoint userver.php. And we controlled most of the parameters for this call. So we could set directly the redirect URI for this call. I would give you a few seconds to understand. So very simple, to post the message, then the Facebook proxy iframe delivers this message to the Facebook app controller, then the Facebook made request to the dialog endpoint, then upon the receiving of the asynchronous request, the Facebook app controller somehow handled this message. So about the handler, how do you think the JSON could be parsed? Well, it's just simply eval. So when I saw the eval, I thought that I could exploit it up to the cross-site scripting. We cannot just redirect. So remember that the dialog endpoint is also the OAuth endpoint. So we can set the redirect URI and to try to redirect the flow into some interesting URL. But the AJAX redirects are not permitted, so if they are cross-domain. So I needed another method to make the calls on behalf of Facebook.com domain. So in order to set the redirect URI to point to something interesting, I needed to first to set the redirect URI to point to the same domain where the request was invoked from. And also I needed to control this redirect URI because there was one check. If the redirect URI was not belong to the application, well, the call was not handled at all. So there was only one way to bypass this via the bug into the flash transport. So if you insert two iframes with the flash transport, if you connect with the same channel, they can talk to each other. And the thing was that there is secret nonce validation into the JS SDK. So the secret nonce is some kind of defense which is made in order to deny any communication with the unknown object. So this upper proxy.svf does know this secret nonce. And this, if I inject some another proxy object from my own domain, I will not know this secret nonce. So I will not be able to submit, to invoke some interesting functions into JS SDK. But the bug was that the proxy.svf did not implement the nonce validation into the input of its own. So imagine what will happen if I inject, instead of Facebook proxy iframe, my own iframe. The malicious proxy.svf will transmit message to the proxy SVF. The proxy does not check the nonce. It transmits the message to the JS SDK, and then everything fails because the nonce doesn't correspond to the predefined value. But in my case, in case of this flow, I need only to submit the message into the Facebook app controller, and I don't need to submit any nonce to the app controller because there is no nonce check. So I just insert two iframes with the two SVF iframes, and I insert the third iframe, which starts the flow. Actually, the upper iframe and the middle iframe think that they are connected. The bottom iframe thinks that the upper iframe is actual JS SDK, it's facebook.com, and the upper iframe thinks that the bottom stuff is going well from a proxy iframe. So I just abused this flow by inserting another third iframe. They connect to each other, and the upper iframe thinks that the origin is facebook.com. The middle iframe does not validate the origin at all. So through the three objects, I initiate the flow, and the upper iframe transmits the message to the Facebook app controller. Now the origin is exactly the facebook.com. Then the Facebook made request to the dialog endpoint, and then the redirect URI pointed to something interesting. I needed to find only the container for the JavaScript. Well, you obviously cannot upload the JavaScript into the Facebook because, well, there is no way to do this. And I've chosen to wrap all the JavaScript into a picture. So another problem was that the save image PHP proxy repacked all the pictures. So it opened the picture, then built the bitmap inside its memory, and then packed everything again. So to insert some meaningful payload was impossible. I divided the payload into two parts, stage 0 and stage 1. So stage 0 was a very small thing. It just allowed to evaluate my own code. And the saveimage.php script itself is another mitigation from Facebook. It made impossible leaking the URL into the leaking the referer from Facebook. So remember the first bug. I leaked the URL string through the referer. So it wasn't possible to redirect to something on facebook.com because even all external content from Facebook is showed through the save image PHP. So all the pictures, all the advertisement you have is going through this proxy. And this is kind of defense from Facebook. I decided to use this defense mechanism in order to exploit the XSS. So I proxied my picture from my own domain through the save image PHP. Then the image was executed by the eval handler, and well, the XSS was exploited. So this bug is personally interesting for me because it's another way to exploit the well-known cross-site scripting bugs. Well, it's not only about filtering, it's not only about reflecting something. With OAuth, you've got a new way to exploit XSS, and with the Rpc, you can also abuse the OAuth control flow. Well, what's another interesting issue is that, well, if you think about the whole web service, like as a node, as a control flow, the OAuth redirects themselves kind of arrows from nodes, and they can be used to propagate your JavaScript. So if you add redirects to your, I don't know, show dialog endpoint or any other endpoint, it can lead to XSS if you, well, if you get some kind of RPC. So during my talk, I think all the bugs were related to tampering the redirect URI. Well, indeed, if you leak something with referer, you need to redirect the page into some controlled, in some controlled way. So if you exploit the token transport to redirect to, for example, you abuse parameters for the iframe, or you just redirect to some old proxy. If you exploit the hash bank navigation, if you pull data from the hash, you also temper the redirect URI. And also, if you abuse the SDK authentication, the issue was that the redirect URI was empty. So the standard, the OAuth 2.0, said that the redirect URI I think may be or should be static, or at least they can be whitelisted. But I think that in the standard OAuth 2.0, this statement should be changed into must, because in case of Facebook, just a single weakness in the standard led to, I think, 5 different ways to abuse Facebook. So that's all. If you've got any questions, I would be happy to answer them.
Are there any questions for Andrey?
Right. About your XSS exploit based on a picture, and if I'm right that you have a picture with a valid JavaScript code, and this picture also a valid JavaScript execution inside the eval.
Yep.
And you have a header with a GIF and other bytes. It's binary bytes, and how you create a valid picture and as a valid JavaScript.
Yeah. Let me return to that slide. So there is another mitigation at Facebook app controller. It's called unshielded message. I don't know how many of you looked into the Facebook app controller JavaScript code. If there are any, just raise your hand. I think no. So all the JSON responses from Facebook are added. So infinite loop is added into the beginning. So you can't inject this JSON into your page and exploit XSS in a simple way. And in order to cut this first part, first 9 bytes, at this JSON, valid JSON response, there is a unshielded response function into the app controller. And I just abused this function in order to cut 9 uninteresting bytes at the image. So the header starts with GIF, 87A, and something like that, and then goes like slash, and then string. So then string ends somewhere. It's a comment.
Right, I understand you.
Huh?
Nice.
So the control data started right at the part of the header where the length was given in the GIF. So with PNG, this magic didn't work.
Okay, any other questions? No. All right, well, thank you very much, Andrey, for your talks.